I thought. Tim, see if you have a mute all. Maybe as meeting organizer only you have that. Okay, so I'm going to unmute myself. All right, and give me a thumbs up if you can hear me, Tim. Beautiful. All right, and my apologies, but while I present, I'm going to go off camera. Give me 1 sec. I thought I had my PowerPoint open. There we go. So I have a quick 6 or 7 slide presentation just to kind of give everybody context. Sorry. Again, my name's Jim Boriotti. I've been with Microsoft I'm a cloud solution architect. I'm a peer of Tim's. I've been with Microsoft for about 2 years. And if you can't tell from the rate at which I'm speaking, I'm from New York. Little past history on me. Before Microsoft, I spent 8 years at Netezza IBM. I came in through the acquisition and supported the data warehousing efforts around Netezza. Great product in its time, but again, an on-premise appliance, and now we've all moved to the cloud or are moving to it. So I was very happy to join Microsoft. Prior to that, I spent 12 years at Oracle. Actually, believe it or not, a lot on app dev side, but also database, of course. So anyway, with that, I'm going to jump into my presentation. I have three goals for today: a quick Synapse presentation, a demo, and then open it up to Q&A. God willing, we have time, and we should. So if you're not already familiar with it, let me just orient everyone. Modern data warehouse, what's it about? It's about pulling in data from various sources. Could be cloud data, on-premise data, could be SaaS application data, pulling that in, landing it in blob storage.
Hey, Jim, are you showing slides?
I'm sorry, I didn't share.
You're good. I just thought I'd remind you.
Thank you. There we go. There we go. Let me just go back. That's the agenda for today. And here we are. So it's about pulling data from on-premises, from the modern data warehouse, that is, from on-premises, can be in the cloud already, or it can be in third-party clouds and SaaS applications. Pulling that data and landing it into blob storage. Once it's there, you may do conditioning on it, and that conditioning on it could be done a few ways. Here we show 2 technologies. We show Azure Data Factory, which does support not only pulling the data from these various sources into the blob, but then working with it, manipulating it, getting it ready for use downstream. Also, I can use technologies like Spark, do some data science, really, do the whole read schema on read, which means land the data as is. Don't worry about structuring it. Just land the raw files, and then let my data scientists, because there's always new sources of data coming at me, rather than going through the process of curating the data first and then working with it. Instead, let the data scientist hack at it, and they may have new sources that they say, let me inspect this, let me get this marking data, I pulled this other data source, let me look at it and interrogate it, and if it's good, I'm gonna move it down the line and bring it into my formal process. In addition to the 2 technologies we show here, you could use Informatica, also an ETL-based technology, ELT, ETL, depending on how you look at it, as well as any of the most of the third parties, pretty much all of them, they support Azure. Once you land that data, have conditioned that data, then the next step would be to curate it and put it into a data warehouse in a structured format and apply governance, as well as support for high throughput, high concurrency kinds of warehousing activities. And in that, let me move this, apologies. And in that process, you then will typically surface the data through Power BI or any number of BI tools. Doesn't have to be Power BI. So we're here today to talk. That's the modern data warehouse process. We're here today to talk about Synapse and where Synapse fits into this picture. And it actually overlays all these things we just talked about, the whole data preparation, data ingestion, data preparation, and warehousing. And even more so, Synapse over time is evolving to support the reporting aspects with Power BI, that is, as well as the storage aspects, that being with Azure Data Lake Services. And you'll see some of that today. So again, we're talking about a platform that integrates this process of pulling the data, landing it in blob storage, conditioning it, doing data science on it, then further landing it in a structured data warehouse, and then surfacing it to end users. So what are the components that make up Azure Synapse, excuse me? There's a couple things. Again, a platform. I'm going to keep using that term. It's not a point technology. It's not a data warehouse. It's not a orchestration ETL tool. It's not a BI tool. It's all these technologies brought together to streamline this process and give a single set of governance and try to share skills, repeatable skills across these different capabilities. So Azure, underneath it, you have Azure Data Lake Service. Within Azure Synapse, and this is today, and this is evolving again, I'm going to repeat it, you have data integration capabilities. And those data integration, as I alluded to, can be done through SQL as well as Spark. So you get to use your familiar old T-SQL to do conditioning of the data, as well as Spark. Very cool new feature with Azure Synapse Analytics is the notion that you can do on-demand working with SQL. So you don't have to pre-provision your SQL data warehouse. You could have on-demand. So why might you use that? Well, you might have, you would typically have provision for your general workloads that you are operating with, your end users working with dashboards, interoperating with the data warehouse, and you may have some on-demand needs for additional user bases that would come into the process and want to work with, intermittent use of the data warehouse. Spark, by definition, at least the way we do it, is an on-demand service. So it starts up on demand, takes a couple seconds to a little bit longer, and will shut itself down. You can set timers for how long you want it to stay up, or you could have it pre-initiated, but it is primarily an on-demand service as opposed to SQL Data Warehouse, which offers both capabilities. This affords you the ability to work in a number of different languages, the ones you're most familiar with. You like being in SQL, have at it. If you want to work with these more data science-y, code-centric interfaces, go for it. On top of all this is a single pane of glass that's been named Azure Synapse Studio. It's this window, and I'm going to show you in the demo. It's this window that allows you to access and manage interact with these different technologies. Capabilities is a better word, excuse me. And wrapping around all of this is the notion of, again, common management layer, governance and monitoring across this platform. And then if you like, you can apply machine learning, AI kinds of capabilities to your modern data warehouse. So again, I know I'm being repetitive, but it's a platform. I want to be very clear because it's not just, data warehouse to data warehouse comparison. Now you should be more broadly thinking about this larger process of modern data warehousing. So some new naming that's been given to these products. We went public preview last Tuesday. And the way we're naming it, the internal components, capabilities of it, we have something called Synapse SQL. So you'll hear me use the term SQL pools occasionally. So it's just the engine, the database engine that you're somewhat familiar with. Synapse Spark, Synapse pipeline. So this is how I'm going to move my data through the data preparation process. And then, like we said, Synapse Studio that sits on top of it gives you a single pane of glass. For some of you, who may have either been working with SQL Data Warehouse or familiar with it, again, its name has evolved to Synapse, and you'll hear SQL pools and support for SQL provision. Very cool capabilities are being released and have been released around Azure Synapse, the SQL pools, things like materialized views. So you can have pre-joined copies of the data automatically created by the database. You just define the view, but it's a materialized view. It's a full instantiation of the database. And what that means is instead of the optimizer having to do the join in real time, the optimizer, when you write your query, even if it has a join in it, is smart enough to say, hey, wait a second, I know I have a materialized view that represents this join. I don't have to do the join and assemble the data. Instead, I can just hit the materialized view. You don't have to do anything. The optimizer is smart enough. Also has things like result set caching. So, the most frequently used queries, it will keep that data in memory, and that incredibly speeds processing. It also helps with concurrency. Besides making queries very quick, both of these things, result set caching does not count against your user count, which is absurdly high. And we'll talk about that a little bit more in a bit. For those who may not be familiar, or Azure SQL Data Warehouse, or now called SQL Pools, Azure Synapse Pools, is a columnar data store. So that's very appropriate for data warehouses. You typically rip through specific columns rather than onesie twosies, row-based operations. It's set-based operations. Group all my customers and let me know what the top 10% is, the average sale for each of those kinds of operations. You're not pulling multiple columns, you're pulling just a few, and doing a lot of summarization, sorting, grouping, those kinds of operations. Well, column-based technologies are awesome at that. Row-based technologies, not so much. Having said that, SQL Pools does support row-based operations, but when you start talking about data warehousing, again, they typically are column-based. And now we have the notion of of ordered columnar indexes. We call our column-based storage clustered column indexes. Just think of it as column-based storage. And what ordered by means is this notion of, as I'm going for those top 10% of customers, we're going to recognize within each data block, before we even read it in, what are the highest and lowest values in that data block, and do they meet the top 10% criteria? If not, I'm not even going to read it into memory, even though that's blindingly fast. I'll skip over that step. So by having ordered clustered column stored indexes within each data page, it's going to record in the system catalogs, which are always in memory. It's going to record the high and low values and be able to skip over those data pages that aren't relevant. And again, we're typically talking about terabytes of data when we talk data warehouses. Just quickly skip. Oh, wait, there could be the necessary value in here, we believe. So really cool technology. We said, I apologize for the dating on this, went preview actually last week. We talked about the different technologies built into it, different capabilities. And by end of summer, colloquially, I'm trying to say that right, the SQL engine, the SQL pools, the Azure Synapse pools. I apologize, I keep changing terminology, but it is evolving quickly. The Synapse pools will be evolving, and this won't be, this is a continuous evolution. It's not just end of summer will be Gen 3. There are capabilities that are being released. Here's a few that were released over time the last few months in different time-based. Well, SQL Gen 3, the big breakthrough with that is going to be merge, which is actually going private preview this week, delete joins, multi-column distributions. For those who know distributed technology, MPP technology, which this is, by the way, neglected to mention, definitely an MPP-based technology. We now will have support for multi-column distributions. That's the way you lay the data on disk. Very simple in the SQL statement, one-time operation. And updatable distributions, that's pretty unique in the industry, as well as multi-cluster support. That's been a big request from customers, multi-column support. Having said that, we do, and cross-database support, online scaling, no need to pause the database when you want to scale up or down. And time travel, I'm stealing a term from one of our peers, I'll call it, a competitor, the ability to see point in time. What was the data 3 months and a day ago? If I ran this query, tell me what the results would have been 3 months and a day ago. So very neat capability. It's important to note, as cool as this multi-cluster support is, we have some incredible and unique capabilities for Azure Synapse SQL pools. We have the capability to do some really sophisticated workload management, as well as query prioritization. The latter one being, hey, my CEO, move him to the front of the queue. Every time he gets online, the supermarket analogy, every time his query gets into the queue, bump him to the front. That kind of thing. So define groups, put people into those privileged groups, and have them always jump ahead of the rest of the workload. Pretty cool stuff. So with that, I'm going to go into the demo. Tim, I'm going to pause for a second. Any questions on anything I presented, or should we hold them off to the end?
Well, looks like you're good. Keep on going.
So the demo, excuse me. Actually, I'm going to pop out of my PowerPoint if you don't mind, and jump into my demo. And let me do this. Discard changes. Discard changes. Let me start fresh. So when you start up Azure Synapse Studio, this is the interface you'll be presented with. So you see the capabilities we talked about, ingest the data, manipulate it, maybe do some analysis on it, and store it in the data warehouse and visualize it. I'm going to start simply with ingest. And for some people in the audience, this may look familiar, what I'm about to go through, if you work with Azure Data Factory. And there is absolutely, definitely, that technology has been built into Synapse. Great technology. So with that, I'm talking about copying data. And typically, let's create a new connection. I can pull data from a variety of sources. SAP, Salesforce, Oracle, SQL Server. Again, it can be on-prem or cloud. Cosmos database, pretty cool. Postgres, it's over. I think it's up to 92 services. Teradata is in that group. TERA. Yep. So a lot of ability to pull data from different sources, land it in blob storage, and then manipulate it as you see fit. For purpose of speed, I'm not going to build that. Instead, I've got some stuff I already built, and I'm going to tear through that if you don't mind. So I'm going to go to pipelines, and I'm going to look at a pipeline I already built. Now, pipeline is a way to manipulate the data. Starts with, and I'll go to SAP HANA to Azure Data Lake Service. I see a pipeline I've built, which is composed of a set of activities where first I'm copying data from SAP HANA. If I look at my source, I can see that I've got a query that pulls, from the fact table. I can see I have a sink. So this is just where it's coming from and where it's going to. And that's a blob service. It's actually a linked service. Is that terminology should be familiar to everyone. So linked service, it's in Azure Data Lake Storage. I can see it's landing in a certain hierarchy. And remember, our blob storage does have the concept, has implemented hierarchical storage. Very useful as I start thinking about landing masses of data in this data lake. And that's the whole modern data warehouse strategy. I'm going to grab data from everywhere and just preserve it. I may evolve it over time from bronze to silver, and then from silver to gold as I move the data through different stages of refinement. I can see where that data is, that it's a linked service within a folder. And if I want, I can even preview the data. So here I'm looking at the data, inspecting it, get a feel for the data, and decide, what I want to do downstream. So that's an example of a pipeline. We'll go a little further into this. If I click down to this mapping data flow, and I double click, excuse me, I see that mapping data flow is itself composed of activities, a series of activities where I'm going to get the data from SAP. I'm going to just subset it to the last 5 years. I'm going to get some derived columns out of it. I'm going to select specific columns. So derived columns, I'm doing transformations. What do I mean? Things like, and I apologize for the rendering. I don't know why this is happening this morning. I didn't have time to reboot a second time before my, mapping, an example of a mapping would be taking a column value and maybe just peeling off the year. And that's how I'm going to land the data. I'm going to create a new column called order year that is just the subset of the order date that contains the year. Likewise for month, likewise for day of year. So I can do those kinds of transformations. I can do code-free transformations, create new steps to do code-free transformations. I'm going to pause for a second, let everybody look at that and take a sip. Excuse me. I'll give you a few more. So I can do code-free transformations. I also have the ability to do code transformations. And I'm going to show you an example of that in a second. So I'll go to back to orchestration. I'm going to close a couple of these tabs in the interest of clarity. I'll pull up another one, my marketing database. And I can go to prep my data in Azure, and I notice instead of being a lookup or a copy data, some of these more code-free based things, I see something that says notebook. And I see that says pulling data from SQL source to the staging area in data lake. So it looks like I'm going from a linked service into the data lake, then prep the data using Databricks. Okay, that's just commentary telling me what's going on. So let's see what that looks like. If I say, excuse me, if I go to settings and I open this, I see a Spark notebook. So here's a Spark notebook. It's currently attached to a Spark pool, I can run in a variety of languages: Python, Scala, Net, Spark SQL. But this is an example of doing transformations, again, whether they're code-free or code at will. I forget there's a term, but code-based, where you want to write your own, maybe for specific business reasons, specialized transformations, that kind of thing. So let's close that and go over to orchestration for Twitter data. I have some Twitter data that I pull into the system. I load some tweets. Now, again, this is an example of pulling data from a lot of different sources, landing in my data lake, cleaning it up, and you'll notice, remember I talked about bronze, silver, gold. I'll keep lots of copies of the data, and Azure Data Lake Service has that hierarchical structure, so I can do very easy to understand, easy to conceptualize bronze, silver, gold, different directories that have different states of the data as it moves through my process, my refinement process. First thing I'm going to do when I get all this Twitter data, this unstructured Twitter data, is land it in Data Lake, and then I'm going to archive it. Okay, I'm going to keep it as is, and that's a key principle. Storage is cheap, especially in the cloud. And then I'm going to go through a process where I'm going to clean up some of the tweets, delete them, and such. So excuse me, that's kind of that. If we look at the copy activity and I look at the source, again, these are Parquet files. If I want, I can preview the data to see what the data looks like. I can also, excuse me, I can look at where I'm landing the data again and the mapping I'm doing of the data. I apologize, it's not set in this case. So that's an example of the Twitter data. Apologize, I lost my place for a second. So we're talking about refining the data, and I'm going to land it. I'm going to land this data, and I can land it with databases, into databases and storage. Here I'm showing databases. I actually have a Synapse data warehouse, which has a number of tables in it. I've landed that Twitter data into a table called Twitter. Let me scroll down. And I see the Twitter data, and I can start manipulating the data through code, or rather code-free. Let me write a quick SQL script to get the top 100 rows, and that's I'm going to run it against the Azure Synapse database, and I'll go ahead and run that. And there are the results. So I can see the data as it's now been landed in the data warehouse. I can do some simple charting, and I don't want to confuse people. This is to inspect the data. As a developer, this is not Power BI end user kind of reporting. This is just, I'm getting an increasing feel for the data so that I can maybe build materialized views. Oh, this is interesting observations. I need to go back to data science and tell them, hey, dig into this sentiment score around this period. Did something happen? Those kinds of operations. Similarly, I could run a notebook against it. So I'll say load it to a data frame. I'm a little nervous about running this at the moment because my Spark cluster for some reason was a little slow to start up before. But in the interest of time, I'll just explain to you that I could, here's the code I run. I could attach it to a Spark pool, actually this one, and I tell it the language I'm running in. In this case, it's Spark SQL. I can click Run All. I'll start the process, but it may take a little bit of time to start up the service. It's starting a Spark cluster, so it's instantiating a Spark cluster. It's going to run the Spark SQL, and we're going to get results. The DF show will give us the first 10 rows. So let's let that run and jump ahead. We'll come back to that in a little bit. Yes, I want to discard my changes. Let me think about where we want to go. So I have multiple engines. Again, I can run Spark SQL. I can run SQL pools against this standard SQL as I choose to work with the data, and I can do both of those operations. Use either of those engines, a pre-provisioned SQL pool, on-demand SQL pool, and a Spark pool, which by its nature is on demand. I can run queries SQL in any of those environments. I can run notebooks in the Spark environment. I can also run any of those two languages, Spark SQL or notebooks, against data stored in a data lake service. Our results came back. And if I run this a second time, by the way, you're going to see, you should see it be much faster because the service is already up and running. Should be faster. Anyway, unless other people are beating on the cluster. There we go. So I can now do SQL-based operations against data that's in my data lake. I might have Parquet data that's sitting there, a series of files. I can right-click on those and pull those in and do SQL-based operations for those who like working more in SQL. let me jump ahead to, excuse me, I lost my place again. Let me jump ahead to back to my development process. Excuse me. And I see a number of SQL scripts. I have SQL scripts, I have notebooks, I have data flows that I work with. I'm going to work with the SQL scripts. Maybe I want to work with pulling in some external data. So what's this about? Well, so here we have this data we've landed in the database. First thing I'm going to do is check if that table exists. If it does, I'm going to drop the table, and then I'm going to create a table called Twitter3, and it's going to in the database, and it's going to load all the data from the copy statement. Will copy the data. This is a new feature, by the way, in SQL Data Warehouse. The notion of external tables and the fact that I can just point at a blob store, in this case, a Parquet store. You see the format is Parquet, and say copy into. So I create the table. Excuse me, let me start over. I drop the table if it exists. I create the table, and then I do this copy into. So let's do this. And then I'm going to select the top 10. And I'm going to do this against a pre-provisioned data warehouse. So I will say run, and we'll see how long this takes. I believe it takes about 8 seconds. And there's the example of the data. And if I want, let me write a little SQL here. Let's how good my SQL skills are under Spotlight. From, and I'm just going to grab the table, dbo.twitter, tw, Twitter3, the one we just loaded, and let's see what this gives us. Run, and I see, okay, 22 million rows, 22,000 rows. If I do, let me just see something here. Yeah, so that's an example of manipulating the data in the data warehouse, doing further manipulation of it. Let me minimize this. I also have the notion of Power BI integration. So we talked about so far conditioning the data, ingesting the data, conditioning it, landing it in the data warehouse, and now we're talking about reporting on it using Power BI. So again, we're in Azure Studio, Azure Synapse Studio. Let me close a couple of windows here. Discard the changes, close that. We're in Azure SQL, Azure Synapse Studio, and I see I've got something called Power BI. For those who aren't familiar with it, it's pretty cool technology, cloud-based reporting technology. And maybe I have my CDP Vision demo report. I can look at that. And this should look familiar to anybody who's worked with Power BI. This is the designer that I work with in Power BI. These are all my data sources that I'm pulling from that exist in Azure SQL Data Warehouse. These are my visualizations I can do. This one happens to be a tree map. We don't need this right now because we're not going to be building or refining the report. Let me just make this a little bigger and shrink this. So what I see here, this is Power BI. This is a live action, Power BI report. I can manipulate it, or if I want, I could go and create a new report, pulling in data, applying creating visuals, and applying filters as I see fit. So I'm pretty much I'm pretty much at the end of the demo. Just to recap one more time, let me go back to my slides and my modern data warehouse view of the world. It's this notion of ingesting. We showed ingesting the data. We showed some Spark conditioning of the data, as well as Azure Data Factory pipelines and manipulation of the data. and then we showed, constantly moving it back and forth from the blob storage, and then we showed landing the data in the database, and then we showed applying, dashboards and such to the data that now resides in the data warehouse. So I apologize if that was pretty high speed, but I did want to leave time for questions. And with that, Tim, I'm going to open up the mic, open up the floor. Are there any questions? Let's start with the chat window. Are there any questions from that we need to?
No, I don't see any. It sounds like a pretty satisfied crowd so far.
Let's open it up to the mic. If someone wants to unmute themselves and ask some questions, please.
Oh, I have a question down here. This is from Arzu, and this is, how did you add Power BI to your Azure work area? I'm familiar with the Power BI desktop, but wasn't aware this was possible.
It's kind of the opposite. Let me jump to my Synapse Studio. Just like Azure Data Factory, excuse me, let me go to process here, pipelines. Let's go to SAP HANA. This is Azure Data Factory capability. If I open up Azure Data Factory, you're going to see exactly this, that I have pipelines, I have activities I create within those pipelines. This is exactly Azure Data Factory, but instead of starting it and managing it and manipulating it as a separate service, it's now embedded into this platform. Well, similarly, Power BI, whoa, what the heck just happened? Okay. I don't know what just happened there. Similarly, Power BI is going to give me the ability to, let me go back to my, sorry, I should be, oh, that's the problem. Power BI is embedded in Synapse, and the way I'm interacting with it is through Synapse Studio. It's this unified single pane of glass that gives me the ability to interact with what previously was SQL Data Warehouse, and is a very evolved product now because it also supports Spark integration. It allows me to interact with Spark clusters. It allows me to interact with Azure Data Factory services, and it allows me to interact with Power BI. I don't have to do anything to embed Power BI in here. I now have it embedded within Synapse Studio, Azure Synapse Studio. Yes. Let me go back to a PowerPoint just to make the point visually. Synapse Studio. That's the window that gives me into these other capabilities, including Power BI. I hope that answered the question.
Yep. So thanks. That's fantastic. Thank you.
Tim, some others on text?
No. Looks like, oh, well, let's see. From KT, it says, can you show how this can be integrated with Azure DevOps?
I cannot.
Yeah, I can't. I mean, could probably figure out a way to create a GitHub repository and maybe
right.
Add the URL to GitHub, but I don't know for sure.
Right, and I need to.
Go ahead.
Go ahead, Tim.
No, we'll look at this question and I'll try to post something to the general discussion area of the meetup over the next week or so.
Thank you. And Azure SQL Data Warehouse does now support, or excuse me, Synapse Studio, when you develop SQL within it, does support the notion of DevOps and moving the data, doing test scenarios and such. I apologize. I'm not a DevOps guy. When I introduced myself, I said I'm a peer of Tim. We're both data and AI CSAs, Cloud Solution Architects. We have peers who are strictly focused on infrastructure, so VMs and networking, all that crazy stuff. And we also have a set of peers that are focused on app dev. And that any of these, as you might imagine, is a deep area with a lot to learn. I'm not a DevOps guy anymore. 100 years ago I was, but not anymore. If we need, we maybe, Tim, in the future, we bring on a DevOps person, talk about the whole DevOps, GitHub stuff. Just a thought. Any more questions, Tim?
Well, no, I'm just going to comment, so I've got these meetings, these Friday webinars set up through July 24th. We'll probably keep doing them, pick them back up in September. But yeah, I'm going to absolutely include Azure Compute, Storage, Network, Security, and DevOps as topics for the remaining meetings.
Cool.
But I'll try to, KT, I'll try to get your question answered over the next week and put it in the discussion area of the NovaSQL meetup group.
Other questions?
No. Like a satisfied crowd ready to rock and roll on a Friday.
Cool. Apologize if that was a little fast, but there will be a recording of it and you can replay it. My email again is jimbo@microsoft.com, JIMBO. Feel free to shoot me an email, copy, probably good idea, copy Tim. And with that, Tim, I'm going to pass the mic back to you.
Sure. Hey, Jim, do you have can you send me your slides, or do you have a link to your slides, like a blog site? Either way.
You got it coming. Oh,
okay.
That's a good point. There are some in my slide deck too, just if anybody's interested. I do have some further slides about build announcements.
Oh, yeah.
New capabilities as they're coming out. And again, these are always, what's the word I want? Subject to change, of course. But some pretty exciting capabilities. Further, just another way to look at this. This is the feature I talked about where there's going to be the notion of compute pools. So I can have different compute pools that are coordinated and working against common set of data. So in a use case for that might be I go hard and heavy on ETL, or I want to segregate certain groups of users and put them in their own cluster so they don't impact a primary cluster. But again, I want to be very clear that it does, and that will support auto scaling, by the way, really cool. But I want to be very clear, you can achieve a lot of that capability today through workload management and query prioritization on a single cluster, which is all we support today. And those single clusters, by the way, can go up to 60 servers. Absurdly big, absurdly powerful, just crazy amount of concurrency and speed. And last slide is some history on how we've gotten to where we are today. So that's all in the deck. I'll publish that to Tim, and I'll send it to Tim, and he'll publish it out.
Sounds good.
With that, I'm going to stop presenting.
All right, thanks everybody. Have a good weekend. Enjoy. I think June 1st is Monday, so here we go, June. Look out on the NovaSQL meetup site. Also the AIML meetup that I mentioned on my first initial slides. Look out for information on how to register for the virtual conferences and further webinars. Thanks, guys. Thanks, Jim.
Thank you, everyone.
Bye-bye.